Hello everyone and welcome to MooTechie. Today, we're diving into the classic machines of manufacturing, the shaper and the planer. A shaper is a type of machine that uses linear relative motion between the workpiece and a single point cutting tool to machine a linear toolpath. It's a really versatile machine, and shapers can be categorized in many ways, as standard, draw cut, horizontal, universal, vertical, geared, crank, hydraulic, contour and traveling head. In most cases, a shaper has a horizontal arrangement. In a standard shaper, for example, this is the really interesting part. Cutting of material takes place only during the forward stroke of the ram. The backward stroke remains idle, just returning to the start position. In a shaper, a single cutting tool is rigidly held in the tool holder, which is mounted on that reciprocating ram. The workpiece, on the other hand, is rigidly held in a vise or clamped directly on the table. The table may be supported at the outer end for stability. So to recap, the ram reciprocates, and thus the cutting tool held in the tool holder moves forward and backwards over the workpiece. Now, this back and forth motion introduces a brilliant piece of engineering, the quick return mechanism. This mechanism is what makes the non-cutting return stroke much faster than the cutting stroke, saving a lot of time in the machining cycle. It's a clever system that uses mechanical linkages to achieve this speed difference. Picture an animation where you can see the crank and link system moving, clearly showing the slower cutting stroke and the much quicker return journey. Let us now look at its larger cousin, the planer. A planer is also a type of metalworking machine tool that uses linear relative motion between the workpiece and a single point cutting tool to cut the workpiece. Now, it's important to note that the term planer can refer to several types of carpentry tools, woodworking machines, or metalworking machine tools. So how is it different? A planer is similar to a shaper in its fundamental action. However, it is generally much larger, and it's the workpiece that moves while the cutting tool remains stationary. In a shaper, remember, it's the cutting tool that moves. Next, we explore the key differences that set these two magnificent machines apart. So what does this mean for you as an operator or a designer? Let's break it down point by point. First, size and capacity. A planer is a larger machine and can accommodate heavier and larger jobs. Jobs as large as 7 meters wide and twice as long can be machined on a planer. That's enormous. Whereas a shaper is traditionally a small machine and is preferred for smaller, more intricate jobs. Second, and this is the core functional difference. In a planer machine, the tool is stationary and the workpiece travels back and forth under the tool. On the other hand, in a shaper, the work is held stationary and the cutting tool on the ram is moved back and forth across the work. It's a complete reversal of the moving part. Third, the type of cut. It is possible for a planer to make heavier cuts and use a coarse feed, really hogging out material, whereas a shaper is designed to make lighter cuts and a finer feed, which is perfect for finishing surfaces. Following this, you'll notice more distinctions. Now, this one might surprise you. A planer, despite its massive size, actually requires less floor space relative to the size of the work it can handle. A shaper, with its moving ram and setup, requires a larger floor space for the size of the work it machines. The drive systems are also different. A planer is typically driven by a gear or hydraulic arrangement, providing immense power. A shaper traditionally uses that clever quick return mechanism to drive the ram, though in modern shaper machines, hydraulic drive is also commonly used. Let's understand this more clearly. In a planer, the workpiece on the bed imparts the feed motion, while the cutting tool gives the cutting motion. On the other hand, on a shaper, the workpiece on the table imparts the cutting motion, while the cutting tool gives the feed motion. It's a subtle but crucial difference in how the motions are assigned. As we continue, the differences become even more pronounced, especially for productivity. The tools themselves are different. Tools used in a planer are heavier, stronger, and larger to withstand the powerful cuts, whereas tools used in a shaper are lighter and smaller, suited for its finer work. This leads directly to material removal. A planer has a longer stroke length and can take heavy cuts, therefore, its material removal rate, or MRR, is high and the operation is very productive. On the contrary, a shaper provides a low MRR, thus shaping is generally a less productive process. And because of its robust construction and setup, a planer has a comparatively high machining accuracy when compared to a shaper. Here's a huge advantage for the planer. It has the facility to accommodate multiple tools and can use all of them simultaneously on different surfaces of the workpiece. In contrast, a shaper has only one cutting tool that can be used at a time. Now, this point is key for choosing the right machine. A planer is usually not suitable for machining small and medium-sized work, one of you at a time. It's overkill. On the other hand, a shaper is perfectly suited for machining small and medium-sized work, one or few at a time. This makes the shaper incredibly valuable in tool rooms and for job shop work. Let's wrap up with the final comparisons. Power consumption is a big factor. A planer, with its massive moving parts and powerful drives, has a high rate of power consumption. A shaper, being smaller, has a significantly lower rate of power consumption. The motion characteristics are also distinct. In a planer machine, the cutting and return speeds are uniform throughout the strokes. It's a steady, constant pace. Whereas in a shaper machine, cutting and return speeds vary throughout the strokes, thanks to that quick return mechanism. We touched on this, but it's worth repeating. In a planer machine, multiple tooling permits machining of more than one surface at a time, which is a massive efficiency booster. Whereas only one tool is used on a shaper at any given time. This has implications for setup. In a planer machine, work setting is a complex task. It requires specialized skill and more time due to the size and weight of the components. In a shaper machine, work setting is far simpler, requiring less skill and much less time. And finally, construction. A planer is very robust and rigid in construction, built to handle immense forces without flexing. A shaper is simpler in construction, and by comparison less rigid, which is perfectly fine for its intended duties. That covers everything on shapers and planers. We hope it was helpful. Thank you.